Okay. First of all, extreme apology for this disconnect. Actually, there was some issue with the permission with the Zoom link and all. So that's how it got some little bit late. But somehow I would be able to manage through my mobile only because the network of the office is not allowing me to join Zoom because it's officially banned. But
No issue,
anyway,
sir. No
so
issue.
I'll request you that you can continue sharing the presentation and then I can, continue.
Okay. Good evening to all the participants of ATAL FDP. Today we have a two session. First we have Amit Anand sir. Mr. Amit Anand is a GIS professional with nearly 13 years of experience in disaster and climate resilience consultancy projects, spanning 9 countries and 15 states in India, with over a decades of expertise in remote sensing and GIS application. He has collaborated with prestigious organizations such as World Bank, ADB, UNDP, GIZ, and regional government to deliver impactful solutions. Currently, he serves as a manager of climate resilience and disaster risk reduction at Price Waterhouse Copper Private Limited, where he specializes in hazard risk modeling, geospatial analysis, flood modeling, project management, and capacity building. Mr. Anand has successfully managed a high profile project, including the assessment of climate hazard and mitigation in Ladakh, GIS cell setup at Ahmedabad Municipal Corporation, and disaster resilience for Assam Power Distribution Company Limited. His international contribution include clean energy transition in Vietnam, Beirut Urban Resilience Master Plan, World Bank USA, and the Ibadan Flood Forecasting and Warming System, World Bank Nigeria. Domestically, he has played a critical role in projects like a national and sub-national disaster risk and resilience assessment for telecommunication sector, CDRA India, and the multi-hazard risk assessment for Jammu and Kashmir. Mr. Anand, notable achievement includes developing the dynamic web composite risk atlas under the National Cyclone Risk Mitigation Project and contributing to the National Hazard Profile for Kuwait. He has a lead over 200 bids in sustainability and resilience domains, managed client and vendor relationship across 20 plus countries, and supervised an 18th member cross functional team. A skilled innovator and leader, he actively represents his organization at industry forums, driving research, capacity buildings, and sustainable solutions to advance disaster resilience globally. I welcome you on the behalf of IPS Academy Civil Engineering Department. Thank you for accepting us letter for delivering your lecture. Kindly enlighten us with your knowledge. Thank you, sir.
Thank you, Swati, for the such elaborated introduction, and really thanks IPS Academy for giving me this opportunity to share my some of the knowledge and experiences with the esteemed participants. Thank you. Yeah, so can I start now?
Yes, please, sir.
Yeah. So before starting my entire presentation, can I request one information that among the participants, which kind of group they have? Are they the sustainability related professionals or the faculties or the groups, or the GIS is their background, or a mix of both?
So we have faculties from technical background, majorly from civil engineering, and we have also people joined from geology backgrounds. I don't think a lot of people are here from the GIS background. So it's basically a mix of science and technical, but not majorly of GIS.
Okay. Thanks a lot. So I have kept my entire presentation onto the application side of GIS because looking at the content of the FDP, I understood that it's majorly focused on the climate risk mitigation and GIS application around that. So I have kept that overall presentation in that way so that it can be maximum beneficial for the participants. The industry use applications, how globally the different challenges of climate change are there, and then how we are taking up some of the challenges and we are resolving that. So with this, I'll start my presentation. Next slide, please. So my entire presentation will be categorized into two major parts. So one is on the introduction of the climate change, and what different climate change impacts leading to acute and chronic both risks, and then the application of GIS in solving some of the real world problem globally. So I'll be basically covering about the three major infrastructure sector, the power, the telecom, and the steel sector, on which we have contributed largely to the global audience. And we will discuss that how different GIS applications uh, have helped those clients in mitigating those risks a little bit, and to a certain extent developing a long-term solutions, pathways, and plans for them to overall address these issues at a larger scale. So I'll be sharing these three different scale assessment and studies that we have recently carried out. In during my conversation also, I'll be talking about some of the more projects which I could not present in the presentation because of some companies IPR issues and all, but I'll be discussing those as well. Yes. So my entire presentation is covered uh, on the theme of a very Simon Sinkins. They have a rule that if you dissolve a problem in three why, how, and what, so you can address the problems comprehensively. Similarly, I have categorized this entire presentation in a way that what basically the climate change is, how it is impacting the global infrastructure and the economy, and then what all are needed to do this, and why the resilience or the mitigation options are required to build a sustainable future. So around that, and how GIS can be implemented in the overall process. So this is how I have categorized my entire presentation. Next slide, please. So under this first category, I'll be talking about the climate change and how the climate change is impacting the across the globe. So what basically is climate change? So I'll start from that. Next slide, please. So if you see my slide, there is a recent finding from the NOAA that the entire world is heating up. And there is a human challenge also, there is a natural causes also. So both are complementing each other and ultimately driving to a climate change. And if you see, there are three basic things in the industry definitions, books, and many research definitions are there. But in a very simple language, climate change basically refers to the long-term variations of the temperature and the weather patterns, and making the entire climate more warmer, more wetter, or more drier. So these are the only three major consequences that we have because of climate change. And it is leading to the many multiple cascading impacts, you can say. So recently, UNFCCC has categorized anthropogenic activities as the main driver for climate change, because the release of CO2 is something that is considered as the prime driver for the entire climate change episode that is happening across the globe. So, and they have specifically categorized a global research group from IPCC, AR5 and AR6 both, that there are physical contributions, and the major areas of the contributions are transportation sector, energy sector, and the agriculture sector, as well as the deforestation. So these are majorly contributing these changes across the globe, in which transportation has the maximum contribution across the globe. So there are good opportunities for the persons who are from the transportation engineering background. Also in energy side, so burning of fossil fuels, though there is a very committed target from the nations, but still there is a long way to go. Deforestation is another area in which now the NBS solutions are coming up in a bigger way. And then finally, the agricultural practices, so uses of different fertilizers and its impact by producing the NOx gases in the atmosphere is something is a major contributor. So they have a maximum contribution if you see the overall scenario globally. And also in India, if you see, the three are the major contributors in terms of the Indian climate change scenarios. So this is what the broadly the research says. In addition, there is also a debate across the globe in which solar radiation, tectonic shifts, volcanic eruptions, and orbital shift. So these are the four natural phenomena that is impacting, because ultimately it is all leading from towards the solar insolation coming to this atmosphere, to the Earth atmosphere. And because of the tectonic shift, there are some geological changes as well. So, and ultimately that is disturbing the overall ecosystem, and that is leading to the abnormalities in the weather patterns and the different overall biosphere, geosphere cycles as well. So, but these contributions have not been established because a long-term data sets are required, and we have been able to capture the climate data sets from 1801 onwards. So mostly we have 150 years of data sets so far for these kind of assessments. But to establish the uh, natural phenomena, we need a long-term data sets of at least of ages. So that is where we have the limitations, and so majorly the entire globe is debating around the anthropogenic activities. Next slide, please. And then uh, all these climate change impacts globally, nationally, or locally have a major impact on basically five key domains, if you say. So one is the global health. And the research says that the warmer temperature is exposing this entire 1 billion population towards the infectious diseases like Zika, dengue, and chikungunya kind of thing. And this is a worldwide problem. So in terms of food security, roughly 94 million people worldwide is facing the insecurity, the food insecurity because of the climate shocks, because of the drought or because of the extreme rains, and the challenges that occurs because of the disturbed agricultural cycle. Poverty is another parameter or a domain which has climate change has a very high contribution in, and around 100 millions of the people across the globe are below poverty line. That is the assessment of the World Bank, and it's a very recent research that has come up. And if you talk about the infrastructure, which climate is directly impacting the acute risk. When we say acute risk, this is the disasters. So climate is a long-term phenomena, and disaster is a short-term phenomena. So that short-term phenomena is impacting the infrastructure system of the globe in a bigger way. And one of the recent studies of the Coalition for Disaster Resilient Infrastructure, which is a brainchild of our Indian Prime Minister, and he has created this particular organization for assessing the infrastructure risk and developing the resilience framework across the globe. And we have significantly contributed towards this particular organization. And one of the research report, Giri research report, says that more than 300 billions of US dollar losses and damages are to the infrastructure because of climate change globally. So this is what the global scenarios are there. Next, please. So as on date, we have talked about the different impacts that we have experienced, but there are also some researches that is around how the climate change will be contributing to the future disaster risk. And there are many researches that I have collated for the purpose of this study also, and for our internal, understanding also, that how cyclone is going to get impacted once we have these impacts locally as well as at the regional scale. So if you talk about the cyclone, there is a prediction that it will be twice if we have the global warming under 2.5 degree. And we have already crossed 1.5. We all are aware about it. When we talk about drought, there is a research that it can just get double in less than 80 years now. So the food security will be a major challenge that we will have in future. When we talk about the floods, so just for each 1 degree of global warming, so there will be an increase in the precipitation intensity, and that will intensify the flood events more than 7%. So it means that there will be a complete extreme events that will be coming up and locally. Then when we talk about the heat waves, it has a direct impact on the human health and the overall availability of any city or the country. And this will impact the overall population by 1.2 billion by 2100. And it is expected that the overall global population will be somewhere around 11 billion, 10.8 billion by 2100. So roughly 10 to 12% of the population will be getting exposed to the heat wave hazards and will have direct or indirect consequences. When we talk about the infectious disease by 2050, so we have an estimated 500 million people will have the issues with the diseases that will be mosquito borne by vector borne diseases basically, and that will be primarily driven by the mosquitoes. Similarly is the case with the coastal cities when we talk about. So sea level rise is something that a country like Vietnam or the coastal states of the Indian continent will have more 20% of their GDP will get impacted because of the climate change. So these are some of the recent researches. All the references are there. If you see that how and it all has a very correlated kind of behavior with the geography in which we live, with the environment in which we live, and with the society in which we live. So we need to uh, consider these impacts at a local scale. There, the research is very big. Research is still pending, and we all need to contribute towards it. Next, please. So then I have tried to summarize the entire challenges globally that we have come across, and there are many factors, and there are many you can say contributors that is leading towards failure of the climate adaptation pathways, targets, and programs. But something, if we address these five parameters somehow, probably 70% of the issues that we have because of climate change can be on a right track, and we can be on a good path of sustainable development, as well as the adaptation will be. Again, it's a global research in which UNDRR has found it out that we are not on the current mitigation trajectory. We are not on the right mitigation trajectory because of three issues: collaboration, capacity, and financing. So government of India is also trying hard onto this, and we need to further assess because we have the global and national scale, but we don't have the NA assessment available at the local scale. So the big area of research that is pending that can contribute to the regional level research, and that can contribute to the global level research. So it will improve the accuracy of the overall research or the findings. So this is an area where we all need, as a practitioner, as a researcher, we all need to work towards it. When we talk about the adaptation investments, so these are definitely not sufficient. So risk informed adaptation is something, it means we don't have a clear idea about our long-term risk and short-term both risk. When I say long-term risk, it means chronic risk, the climate change risk, and short-term risk, that is the disaster risk. So what could be the potential disaster risk in a region? Multiple hazards we have in different regions, and its consequences we all are well aware. But in different under different scenarios, what could be the potential impact of those hazards in our region, and what could be the investment that is required to prepare ourselves better, or to prepare the infrastructure better, to prepare the community better. So those investments needs to be planned again at a local government level, at a state government level, and at a national central government level. So that assessment is also lacking, and that's why, and similarly, that investment drive is also not there. When we talk, there is something very important we call as a residual risk. So a risk that is always there. Whatever you do with the disasters, the natural hazards will come, and it will have some sort of impact on the infrastructure, economy, and the people. But there will be some risk that will always be there. That risk should not be compounding in nature. So what preparedness we should have if we face an extreme catastrophic risk, or if we see a moderate risk, or if we see a low risk hazard. So that is a big area again to understand, to research for various infrastructure systems, right from the civil infrastructure to electrical infrastructure to electronics infrastructure, even for the geologists, how the entire land mass, the urban planning is going to get impacted because of these natural changes, or because of the extremes that we are experiencing. So this is the third area. When we talk about the fourth area, financial systems, our entire banking systems, as you all are aware, recently Reserve Bank of India has come up with a guideline. We call it NGFS. So that guideline basically guides the entire banking system that how to consider the climate risk and disaster risk into their overall loan portfolio. And going forward, all their collaterals will be based on the risk of those collaterals because of the climate and disaster risk. So there is a long debate going on. PwC is again a part of that the forum, and we are giving our recommendations for how to make it robust so that there should be a standardization of the risk assessment methodology, and that can clearly guide the banking system that how a financing can be done for a different risk appetites or a different risk profile across the regions. Similarly, there are some policy lags. I'll be discussing about these policy lags, that at what level we have. So once you have a good research that is backed by some good evidences, and then if you put into the system, so and we have helped governments, international bodies in changing some of the recent policies that government of India has. So I'll be talking about those in detail, and that is basically also addressing the gender equality, the overall community participations and all. So all these policy level changes is also getting driven if you have a very good research at the ground grassroots level. So this is all on the underlying challenges that we have, and this has been grouped. If we are able to manage this risk, probably these risks will be very minimal, and probably we will be at a level where we will just have a residual risk or some risk above the residual risk. That will help the overall ecosystems to live sustainably and to be well prepared from these risks. Now, so with this, and since these were the global issues, the whole world have been researching around this. In 2015, three landmark global decisions came, one as a Sendai framework, another as a SDG, and third as a Paris Agreement. And it all happened in 2015. There was a specific reason that why 2015 was such a big year, because Hugo framework was ending that year, and there was, and disaster was a consequence that was felt across the globe every year. And 300 to 350 billion dollar is the economic loss that every year world was facing. But at the same time, there was also a need to develop some goals across the sectors that can ultimately contribute to mitigating these risks. So the SDG came into picture that way with the 17 global goals. And then mitigation was not touched upon because both of these actions were largely related to the adaptation side. And mitigation was just touched in the name of greening. But later on, the Paris Agreement suggested that no, we need to, whatever way we adopt, we need to mitigate the overall carbon footprint from the atmosphere. So all these, and in addition, there were also some, individual kind of work that was going on for the hazard risk assessment, and those things were going on. But these three problems that were discussed at global level, a policy were formulated to address this entire issue at a system scale. So when we say system scale, it means it's not just one infrastructure system or just not one society, or just not, we are not just talking about a single economy or anything. So it's a global in nature, as well as at the same time it's a local in nature. So it's a feedback kind of system. So one going giving an input to the another, and other giving the input to the first. So risk and resilience can be established across the entire globe. So that was the overall agenda of these frameworks. But having said that, these initiatives have supported and started supporting by and large the different innovative resilience solutions to build the sustainable future. However, there are many gaps that still exist on ground. So the next slide is on to those clear gaps that we have on the ground. And so if we talk about those issues, so disaster is one of the issues that everybody faces, and we have very clearly experienced it. So not a single people on this entire continent, in some way or the other around, they must have experienced this issue. And GIS, basically the entire globe has accepted it, is one of a very robust solution that is available to the human mankind now to play some very key role in mitigating these risk impacts. So GIS as a technology, GIS as a solution, and GIS as a tool, both can help the overall economy, the infrastructure, the system, the overall stakeholders to take these initiatives in a very faster way. I'll show you now some of the examples, but before showing that example, uh, we have indigenously developed a very unique framework for this country. Uh, and even that can be applied globally, that helps in assessing this entire climate risk and impacts on a GIS platform. So that's one thing. Second thing, why we have used GIS? The reason is it has the entire capability of location based analytics that can identify different patterns, trends, and long term impacts. So, a long term phenomena can also be understood through GIS, as well as the short term phenomena on a spatio-temporal scale can also be understood. When I say spatio-temporal scale, it means anything can be inferred at the spatial scale. When I say spatial scale, it is right from a point scale to a polygon scale. When I say point scale, it means just one coordinate of any place to the entire globe. We can have the assessment. So that way, GIS has been designed as a tool. So it's a location plus IT tool, if I have to simplify it, but it has a very good feature of layering. So it has multiple layers of capabilities. So if you see the right hand side, I have just presented one schematic in which right from a real world land use land cover setup, whatever LULC you have, to the different elevations of that land or geography, to the different land uses, what is being practiced at different scale, right from village to national scale, to the different boundaries what we have based on the geopolitical definitions. It can have the information of all these layers and then individually also or on a combined layer also. And when we integrate these information with the hazard information, with the climate information, we have multiple kind of assessment for the risk, understanding of the risk, for taking the different risk and resilience interventions, and also the different hazard risk analysis, all sorts of strategies that can be developed for emergency preparedness, response, recovery, and then the overall hazard mitigation plans that we develop for a longer period of time. So this entire thing can be done on a long-term scale. If you see the whole climate change and disaster, the climate change, climate risk impact analysis, long-term climate impact analysis, short-term climate impact. When I say long-term, it's more than 30 years. When I say short-term, it's more than a decade. So all those assessment, the where are the emerging risks, where are the continuous risk, where are the base risks. So these are different definitions, which is impossible to cover in this 1 hour of presentation, but it's a very interesting area for different engineering background people, because vulnerability is one concept that is at the core of this entire assessment. And vulnerability is hardcore engineering. This entire country has a one very big challenge as on date, is that it has no vulnerability module for any of its infrastructure system, whether we talk about any of the physical infrastructure system, roads, railways, power, transport, telecom, any infrastructure system. We don't have any information that how these infrastructures will be behaving under different hazard scenarios. So that's one very big research area again for the faculties as well as for the students, in which one set of infrastructure can be taken as a research and then how it is behaving for different hazards, maybe for one hazard, maybe for multiple hazards. So cascading and compounding, both hazard impacts can be assessed through this. Next, please. So there is a GIS use case uh, that I'm going to present, and this GIS use case is basically uh, the projects that we have done for three major sectors. One, as I said, power sector, another for the telecom sector, and third one is for the very big steel conglomerate. Uh, so I have shown it purposefully, these three. The reason is, if you see the disaster impact, as I have said, the transportation is the first sector, and power is the second sector that is largely getting impacted, and it is largely contributing also to the global damage and risk losses. And both these infrastructures have the backbone as communication as a backbone. So telecommunication growing in the growing digital economy is an infrastructure that has an impact, and it is actually impacting this entire ecosystem. In a way, it is getting impacted. So to start with, I'll discuss about the first GIS use case that we have. Next, please. Before giving this overall assessment, I will share a little bit about this framework, that how disaster risk and resilience assessment frameworks works. And this is one of the very important slide of this particular FDP. This comprehensive framework you will not find anywhere across the globe. This is a very unique research work that I carried out after working almost 14 years in this space. That how these are over interlinked, then these are over different layers. So I'll just explain a little bit in for the simplicity of everyone. So we have considered two major risks. One, and we have grouped it like this: one is the acute risk, and another is the chronic risk. So right from the left block, if you see, hazard risk diagnostic is the first block. So in which we simply assess the overall hazard risk. And when we talk about hazard risk, both acute and chronic. So when acute risk, we are talking about different historical events, their location, their intensity, their probability of hazards. All we assess. Then on the chronic risk side, the temperature, the precipitation, the sea level rise, the sandstorm and dust storm impacts locally as well as regionally, how it is impacting each other. And then it is ultimately creating a hazard scenario that we call is hazard risk diagnostic. And then we create a hazard risk impact register. That register has four basic components. One is the hazard intensity of that particular location or that particular area, what is under study. Then the second part is the hazard frequency, that what is the return period of this in last 5 years or 10 years or 50 years or 100 years, how many times that hazard have impacted that particular region and at what intensity. Then the third is, which is again a very big problem at a national level till date, and we are debating with Ministry of Home Affairs as well as NDMA both on the hazard durations, because flood is a hazard that has a very long, drought is a hazard that has a very long, though we define hazards or a disaster as a short-term phenomena, but it has a cascading impact if the durations increases, even if the intensity is moderate or a low, but if it is for a longer period of time, it has a very different kind of impact. And that we have come across mostly in the northeastern region. Assam, which is one of the state, has 35 districts. Every year they have 3 to 4 episodes of flood. And from last 10 years data, if you analyze from 2015 to 2024, you will have minimum 3 episodes of flood, ranging from 90 days to 235 days in a year. So that's the level of inundation they have. And it is disrupting their entire economy, right from infrastructure to people to supply chain, everything. So the duration of hazard is something that is not being talked about, that is not being captured. So how it is impacting the overall infrastructure as well as the society. So, and the fourth parameter is the spatial extent of the hazard. If that is a very localized kind of hazard like landslide or a rock slide or a volcano, or a very long area hazards like a cyclone, which has a very huge impact, or a windstorm or earthquake like hazards. So since we are talking about the climate induced hazards, so I'm not considering the geophysical as of now, but these hazards are generally mapped on the GIS scale. And then on the GIS, at different scale, we map it based on the requirement of the project or based on the requirement of the research. And then we model these events. So that's one thing, is mapping based on these 4 parameters. Another is modeling, that how these scenarios will be in future for this region, considering the local topography, or we call it the orographic effect, the local weather effect, and the regional weather effects. So based on that, we develop the hazard risk diagnostic. This gets into the assessment of the technical standard of the infrastructure also. So whatever infrastructure is there, it has some got designed 50 years ago, some got designed 25 years ago, and those design parameters are no more working on ground. That's why we have such a long impacts. There are some cases key. This is not because of the infrastructure design failure. There are many debates around this, but it is because of something else. But though something else is also contributing towards the design standards. So we are debating with the power ministry, we are debating with the telecom ministry, we are debating with the road ministry, we are debating with the railway ministry through 4 different projects that I'll just be talking about. And then we assess the different gaps in the infrastructure system. So when we say infrastructure system, all the physical as well as natural infrastructure system. If there is a river, it is meandering. What is the rate of meandering and how it is meandering? Does the soil erosion have a contribution in its meandering, or the local topography has it the sole contribution? Similarly, if there is infrastructure that is planned for 10 years or 20 years, like telecom or power infrastructure along these river channels, so how these will be behaving or how these will be impacted during the course of low, medium, and high hazard scenarios. So all these things we assess here. Then we input that entire data into the risk and resilience module, which is based on the spatio-temporal scale. So both we have again 2 modules into this. One is the climate exacerbation module, another is the hazard module. So probabilistic hazard modeling that we carry out if that assessment is required for the hazard assessment, if that requirement assessment is required for the climate assessment, we carry out the climate scenarios modeling. Earlier there was different RCPs. Now after the AR6, the SSPs have come into picture. So different SSP scenario based on the local and regional biases that the models have, the global models or the regional models have. Accordingly, we do the bias correction, and then we correlate with the historical data sets of those weather patterns. And then finally, we develop the vulnerability functions of that. We have started doing it. We have just initiated for this country level vulnerability profile development for telecom infrastructure system. And that's the first vulnerability profile that is getting done for this country. Otherwise, as on date, we have a practice of taking the references from Hazard's FEMA. They have the building vulnerability modules, and we take that, and based on our local experiences, we tweak those vulnerability modules. But these are no more working across the insurance industries. That's why there is a big failure in the insurance industries. And so government has come up with an idea that you develop the indigenous. This is a very big research area in which we need to understand the fragility and the damageability of any infrastructure based on the hazard intensity and the local parameters. And then the overall this exposure module is something that we all know that whatever infrastructure is there, we just map it on the GIS system. So whether it is a road infrastructure or a house infrastructure or any of the land use, land cover, whatever infrastructure is there into that can be mapped. Again, that exposure module is an input to the vulnerability module, and those risk and resilience different scenarios. So risk scenarios basically first, the climate and the hazard, both gets fed into the vulnerability module. Once we have this hazard, exposure, and vulnerability ready, then we come on to the risk assessment. That risk is, again, we have 2 types of risk modules. One is the physical risk module, another is the operational risk module. So in the physical risk module, we simply talk about what is the probable maximum losses or the average annual losses of the infrastructure. And when we talk about the operational risk, how the different industries or the government or the infrastructure or the supply chain operations will get impacted. So we have certain parameters like downtime, production losses, revenue losses. All these parameters can be assessed over the period of time. And then using all these informations, we develop the resilience strategy, even at the government level, at the industry level, at the different infrastructure levels. So whosoever is the stakeholder, depending on that, we have a different resilience strategy developed. And then finally, we quantify those risks as per the need of the infrastructure damage as well as the operational downtime. So how it is impacting. And then there is a new concept that is coming up on the transition risk side, that what different transition risks the government may face because of the climate change or because of the disaster impacts locally. So that is another area that is getting addressed through this module. So this is the overall framework, very comprehensive in nature and basically adapted from many resilience frameworks across the globe. And if you see, this is one of its comprehensive framework across the globe that you can apply in any and every disaster and climate risk impact assessment exercise. Next, please. So I'll be first now talking about the one study that we carried out in Vietnam. So we were given this was a World Bank assignment, and we were given a very typical case that the entire Vietnam is facing a transmission loss of very high transmission loss, and some $72 million is spent on a power backup because of the flood, sea level rise, and the cyclonic. There they call it typhoon, so cyclonic wind storms, and there is some 670 million loss to the Vietnamese front because of the electricity outage, and it's a very old data. Then we started our analysis, and we used the GIS to assess what is for different return period. I have just shown 150-year return period flood inundation assessment. We modeled the entire event, and we understood these all the green points are the substations, and all the pinks, these are the 500 kV lines, and 220 kV lines, sorry, are the green points. And so those substations, where are those and how it is getting impacted? So the overall flood risk profile, if you see Ho Chi Minh and Hanoi, both are the maximum flood prone zone, and they have the flood depth of 1 to 2 meter to 2 to 6 meters. So we categorize that as a high risk and low risk flood areas based on how their overall flood profile are. And then we model that event, and we corroborated that with the field observations. So we found that some 83 substations are exposed to the category 2 and category 3 100-year return period. And similarly, in the flood, we found that some 12 substations are exposed to a flood depth of more than 2 meter. And that is, these substations are generally at a height of 10 meter or 20 meter, not more than that even. So what different resilience interventions can be taken using this? Then in different scenarios, how the flood will be increasing, so how much they need to increase their foundation heights and all. So that is what the suggestion was. Similarly, there all the electrical apparatus, how much they need to build their foundations, basically raising their heights of those electrical status. And then if there is a persistent problem of flood because of the duration, so what they should take as a precautionary measure in terms of flood proofing. So all those recommendations were given. The right hand side, if you see there, this is a map of the cyclone for a 100-year return period cyclone. We assessed that entire country, and the wind speed from 43 kilometer per hour to 250 kilometer per hour, even more than that. We tried, but Vietnam largely lies in 200 up to 200. So how the different infrastructures are lying into that, and what if the different wind speeds of different typhoon agents changes, how the low or the high vulnerability areas impact will have the cascading impact on the low vulnerability areas, and this entire network will have outage issues. So how to address that, where we need the strengthening. So all these recommendations were given because of the PR issues. I have not given those numbers to you because it's with the agencies. So that's one very important assessment that we carried out for the Vietnam. And Vietnam is the first country, they have developed this entire hazard risk, power sector hazard risk assessment and the resilience pathway development for this entire country. So in India, it has just been carried out for one state, Odisha, so far. And we are doing it in Assam, but again for one sector only, and in Gujarat, just for the transmission and distribution only. But Vietnam did it for this entire power system for the country, and similar kind of program is being planned out in India as well. Next. Now, this is another study that we recently carried out for the telecom infrastructure resilience. So if you see, this is for one of the cyclone-prone region of this country, that is Odisha. And Odisha has the maximum cyclone impacts. And every 2 years, if you see last 20 years data, they have almost 10 cyclones. So their return period of cyclone is almost 2. So every 2 years, they have one cyclonic events on an average, and it largely impacts the telecom infrastructure into that region, and which impacts the preparedness, response, and recovery, all activities in the coastal as well as inland region of the Odisha. So Ministry of Communication came to us and they gave us the challenge that can you suggest that we are following all the design standards and everything, but still there is a big cases of outages and network outages and communication failure. So where are the problems? So we started analyzing and we found that there's 13% of the tower that exists across the state are in a flood prone zone. So there all the generators that are put in at the ground level needs a raising of heights of those generators to perform it during the flood time. Similarly, there 57% of the towers are vulnerable to very high and high. When I say very high and high, it means more than 170 kilometer of wind speed. And at that wind speed, all the Indian telecom infrastructure antennas are maximum designed for 160 kmph. So there is a misalignment case, and the moment there is a misalignment, this entire uh, communication systems gets disrupted, and because of that, their entire activities of the disaster management gets failed. So identifying those sites, we have specifically highlighted the number of those sites. Now moving forward into the new era of 5G, there is a densification at the network. So some of the houses which is at one floor but have an inundation of 2 to 3 meters in that area, those RDT towers, these rooftop towers, are getting also impacted. So that's another challenge they have, that at what level, what building should be selected for the telecom tower assessment. So there is an entire policy framework has gone around this, and TRI and DOT are changing their some of these standards. How a SATCOM can come into picture, and where how much of bandwidth is required based on the vulnerabilities of these towers. So those kind of recommendations we have recently submitted to the Department of Telecommunication, Ministry of Communication, and there is a national debate that is happening next month onto this. So all these stakeholders are involved into it. And this study we carried out for Pan India and 5 states: Uttarakhand, Gujarat, Orissa, Assam, and Tamil Nadu, which has almost all the representative hazards of the country. So it was a multi-hazard risk assessment study for this entire telecom infrastructure system. Next. There is also a problem. India has a digital broadband mission. So one of the project came to us and they said that Gujarat is very aggressive, as we all know, and they have the coastal infrastructure. So what they did, that they very aggressively dig their entire road networks, and they laid the OFC cable network for the faster broadband connectivity across the state. But they always have a challenges of these optical fiber breaking across the estate. So this problem came to us, that what is the exact reason why it is happening. And then we understood that there 46% of the ES. So we did this particular study at a district level. So Jamnagar and Dwarka, these are the coastal states and very highly prone to cyclone, storm surge, and floods all. And all these regions are into zone 4 and zone 5 of the earthquake. So if something happens to these regions in terms of earthquake or cyclone, their terrestrial infrastructure will get impacted. So just having one broadband scaled up for this entire state is not going to solve their entire problems, because all these terrestrial infrastructure is exposed to very high hazard impacts. So some more than 46% of this OFC network are into the storm surge reason of a very high storm surge region. Similarly, in Jamnagar, so the number are more or less same. So we have suggested them that as an alternative communication, you should have a radio communication as well as the satellite communication for these regions, because if these infrastructure fails, you can have the redundant infrastructure system. So that's one. Similarly, for the emergency connectivity, and since these are border areas as well, so how we can have the coastal communities saved from the international boundaries for Pakistan and all. So from the Kutch side. So again, that area is highly exposed to the cyclonic windstorm. So how to have those strategies in place so that the frequency can also be controlled at the same time. We can have a very robust kind of infrastructure. So this is a very critical study. Again, there are many findings. This because of some limitations, we could not share that. Next, please. We have recently developed a supply chain risk assessment for asset level plant, and this problem came with a very big conglomerate of this country, again because of the reason we are not sharing, because this site is quite sensitive in itself. And if you see in the left dot, so there are many hotspots that we have, and those hotspots are the landslide prone zones, and next to those areas there is a connected road. So those connected roads are basically landslide prone, and during the monsoon season for 2 to 3 months, almost 4 months, their entire supply chain disturbs. So they have a huge economic loss because of that, and they so economic loss for the state and the financial loss for this company. So a problem came to us that how we can plan our supply chain well in advance, and considering what. So we started assessing that, and we understood that the rainfall pattern of that area from June to September, how it is behaving, and that particular problem was, and for different years, then how the different rainfall intensities and distributions are basically impacting the slides. Then what are the critical locations of those slides, those landslide hotspots, and then what are the alternate paths that can be taken to assess this. And then we recommended. So, and also what different kinds of landslide movement, how fastly those landslide issues can be resolved by the local administration. What are the different landslide movement rate and all. So we have done that, and some 176 landslide locations across that region we found that are there, for which at least 20 locations they need to fix up to have a very robust kind of supply chain. So that can means fix up means either the state government, they should request the state government, or they can have the advanced planning if those areas get impacted. So there is again a very different sort of recommendations that went into this, and this has helped the client. So client has given a pan-India site, right from the hilly areas to the coastal areas of the eastern coast and western coast both, that how a different supply chain can be planned. So these are just the applications that I'm showing, and this is all on GIS platform. So all location-based analysis, all the analysis that are linked with right from finances or the economics to the engineering or to the infrastructure. So all, even the social science, there is a huge cases of community violence and all across these regions because of these issues. So how to tackle that? Where, how, when to give them the advanced information about these issues, and how the different progresses are being made for managing those issues. So all those kind of recommendations we have given to the local administration as well as to this client as well, and it is being forwarded at different levels at the state administration as well as the local district administration. So I think with this, it's almost, yeah. And one last thing, these are the four. There are many, but these are the four open source tools that is available globally. So one is INASAFE, another is RISCScape, third one is the Hagis, and fourth one is the Capra. I'll request all the faculty members to go through this, because these are the four software or the tool GIS. These are all GIS based tools. Little bit of exploration, and there is a good amount of literature available for these references. If you go through this, you can have a very comprehensive understanding of how this entire climate risk assessment, disaster risk assessment for multiple scenarios, acute, chronic, both, can be done at different scales. So right from local scale to country scale. So and to me, these have been the references from last 10 to 14 years working in this space, and these are one of the best. I cannot say this is a complete one, but it can give you a very thorough understanding of this entire hazard risk assessment. So, and it is all GIS based. So, and this is open source, so anybody can try just with a simple login, and it's a good reference to refer for at least for next 5 years of research. So, with this, I'll end up, and again, once again, apology for being late a little bit. Thanks a lot from my side. I think I have covered that entire topic in 1 hour. Thank you. Any questions if you have, I can address that, or I can answer that.
Yes, sir. Good evening. And this is Dr. Rajshri Kamath, Associate Professor, MNIT Bhopal.
Yes, ma'am.
I had been working in this area, and your presentation is just too good. And I never thought that I'll be coming across some expert who will be explaining all these things, and I had been struggling a lot for working in this direction only, you know. I had worked for vulnerability assessment for World Bank projects, for on-site, off-site emergency management plans and all. And right now I'm teaching, and I'm teaching students to proceed and work in this direction. And I'm also coordinator of one ATAL FDP in second week of January for disaster management and sustainable resilient cities. So I wonder what resolution remote sensing maps you all are using in PwC for all
Ma'am,
these
right
works.
from 1 meter to 30 meter we are using. But
Okay.
that 30 meter is no more a good reference for us if there is a very generic kind of requirement. Otherwise, 1 meter to 10 meter is the resolution that we are basically using for different project purposes.
So I'm definitely calling you in one of my conferences or these type of FDPs or something, because then we will be having our city planners, architects planners, who will be asking in detail each of your projects that you have worked.
Yeah, sure, ma'am.
I've
Well, they
also
will be
written
there.
like 4 books. Out of that, one is on planning model for earthquake and flood-prone towns.
That's
I've been
really
working
great.
on multiple disaster scenarios also. So I had gone down into detail as an architect planner and in a team of civil engineer and chemical engineers also on SAFETI and creating models for on-site, off-site emergency management plans for Punjab district. And in fact, I belong to Bhopal, where the worst chemical disaster had taken place.
Yes, ma'am.
So I had worked in Disaster Management Institute, Bhopal, which was the first DMI. So now I am Nodal Officer and IDM UNIDRR, University Institute Network. So thank you so much. There are so many questions and there are so many things you are right now working on the important infrastructure all over India and the world. So
Thank you,
where
ma'am.
can
I'll
I
be
get
happy to
all?
be in touch. Yeah.
Yeah.
So, my email ID is there, and we can discuss anytime any sort of issues, because more the challenges come to us, we try to solve it, and industry works on its own pace. So little bit of that advantage I have. So if there is any problem, I try to find out a way how to solve it as fast as possible. So funding is never an
So where
issue
can
to us.
I yeah, okay. Can I have detail this methodologies and works, because I had been through hazardous radius and all the things that since 2003.
Yeah.
So this is my basic interest apart from all other routine things that I had been doing. So this is my research area. So I'll be contacting, or if you can give me any detail like books or anything that you might have written, or to refer where these case studies are there, or if you are interested, you can write books also. I'll recommend you, because
Ma'am,
these are very
I'm writing.
good
I'm in process of just
books.
don't want to disclose it, but since you have asked it, I'm writing one book on mathematics of disaster. You know, that's a
Oh
very
wow.
that's a very unique kind
Wow.
of book this country does not have till date. So I have started writing onto that. A few chapters are already done. So in which
Okay.
I'm covering the hydrometeorological disasters only, ma'am, because I'm not
Okay.
expert of geophysical, because my area of interest
Okay.
is hydromet only. So all the climate-induced disasters I'm covering into that. I will try to
Okay.
collaborate if once I complete that, and it will take another 6 months to 8 months according to my different responsibilities for the firm. So and since there are many global projects, so most of the time I'm not around. So that's another challenge. But yes, whenever I get a time, I try to complete it in sections. So it is
I'll
getting.
be in touch with you. Yes, on your email ID. So please send me the link. I'll circulate that and we'll purchase for our institute also.
Sure, ma'am.
And there are many questions, but now I give this opportunity to other
No, ma'am, you
participants
can
also.
write me, or we can have a word. You can take my
Yeah.
details from the professor's
Devanshi,
page.
yes, I'll take.
Yeah.
Yes, yes.
And we can discuss. This is always a very interesting area for me. So, yeah.
Yeah. Thank you so much.
Thank you, ma'am.
Thank you.
Any other participants would like to
Yes.
have any queries answered?
Yeah,
You can
good evening.
or
Good
you can
evening.
also type in the chat box.
Yeah, good evening. I am Dr. Vinishwi Nair from RIT Government Engineering College, Kottayam, Kerala. Am I audible?
Yes, yes, sir. Please go ahead.
Yeah, your technical talk was highly informative, and especially your slides were highly appealing. And my query is about that risk resilience framework. You have shown a very comprehensive risk resilience framework. There we have two modules, especially the climate module and the hazard module, right?
Yes, yes.
Yeah, and about the climate modeling, we can take RCP scenario as well as SSP. Right now, we are using SSP scenarios.
Yes.
My question is about the other thing, hazard modeling. I think you have used some probabilistic hazard models.
Yes.
Can you list some of the hazard models you have employed in your particular work? Yeah.
So, sir, there are many hazard models. If I have to say, just to list with the flood one. So, in flood, we use 3-4 models. One is the HECRAS HTMS, which is an open source. At the same time, we have the proprietary flood model. We call it MIC. And it has the best sediment transport module. So, wherever the area which has a very high sedimentation issues or the erosion issues, generally we consider using the mic. For the general purpose riverine assessment or modeling, HECRAS, HHMS is something that we are using in general. Then there is another model that we call a SOBEC model, sir. So we do that. So we are using that model as well. Also, sir, Lyson is a model that we have been using. Not too much, but for the specific cases in Uttarakhand and the Tarai region, sir, basically. So the UP Tarai region and the Uttarakhand region, so that model is functioning very well for that reason. So these are for the mountains to plains, sir. When we talk about the coast, so coastal flood, coastal hazard, we are using Tsunami model, sir, for storm surge and cyclone risk modeling, basically. So that is again an open source model, but this model mostly works on the Linux platform, sir. The rest of the models, whatever I have said, it is all compatible to Windows, but that model mostly have a good functionality with the Linux application.
Yeah, I understand. Then HECRAS in that work in Vietnam, where you prepared that flood inundation map, have you been using that HECRAS model or MIC model? Because MIC is...
So we have done this entire assessment using HECRAS there and the Tsunami. The two models we have used for the coastal inundation, we have used Tsunami and HECRAS for the inland flooding, sir.
Okay, good. Because HECRAS is an open software, but I think MIC is not an open software, right?
Yes, sir. It is a proprietary of DHI, sir.
Yeah. Thank you, sir.
Thank you.
Anyone else from the participants? You can also type in the chat box if you have any questions. I request the participants to please switch on their camera if possible.
Can I have one question?
Yes, ma'am. Please go ahead.
Sir, all these studies when you do, is there anything in particular your observation? Because all these we can relate to insurance and compensation also.
Yes.
I had contributed one of the chapters for one of the textbooks by NIDM for disaster management. So few chapters I have contributed. So this particular topic is the most difficult topic, insurance and compensation, when it comes to disasters, right?
Yes, ma'am.
So you please enlighten on this because you have such a vast experience.
I'd like to give you a very brief, theory about this insurance industries. So basically, how it works, ma'am, that there are two models in insurance. One is the general insurance model. Another is the parametric insurance model. So general insurance model says that whenever you have any hazard, whatever is the impact or the losses or the damages what you have, that gets certified by the local administration. Once I say local administration, it means the district magistrate, the DDMA officer. And then it goes to the respective SDMA for SDRF fund, because in India we have a provision of funding through SDRF to mitigate those. Now, another side of it is the insurance. So that is a normal financing for the disaster. When we talk about the insurance side, so there are certain limitations on the insurances, that the infrastructure, if it is fully covered and the return period is very high, then the premium goes to an extent which ultimately after 10 years down the line, if you see 10 to 12 years generally is the timeline, do your entire asset amount has the value of that insurance premium. So that is the risk that we have. So generally a market, what they does, 10% to 30%, they keep it as a threshold for ensuring their highly vulnerable asset. So that's a practice they have. Sometimes it is working in some cases, like a moderate hazard region or extreme hazard region for a very long return period. But when we talk about a very frequent disasters with a very high vulnerability, then those things are no more working. So in that case, the insurance models are getting failed. So now different sectors are coming up. They are saying that you develop the parametric insurance model for us and you give us. Again, in that parametric, there is a problem that you have a specific hazard events and it has an impact. So there has been you can say a cases with different line ministries that says that who will be certifying the exact reason of that damage, because we have not seen the impacts on ground. So this is a very high debate that is going on. To avoid all these things, there is a general insurance model that is getting practiced across the country, and this is getting a good traction among the stakeholders. And they are calling it, and there are certain tools for those insurance values. So one is, ma'am, the cat bond. So now government is coming up with different cat bond ideas for the high risk region like Odisha, Uttarakhand, Kerala, and for a specific hazard, not for all the hazards. So as you know, some disasters are state notified disasters, some are centrally notified disasters. So if this is a state notified disaster, in that case, all those funding and arrangements will be limited to the state insurance regulatory authority. So all those certifications and those validations, everything will be done by the state administration. Once this is centrally notified disasters, in that case, it will have a central government or a central agency's involvement into it. So there are many challenges, but when we talk about the overall insurance landscape for the disaster, so disaster risk financing, we all know, and I have a specific, this Vietnam project and this telecom project, both have a disaster risk financing component. So I have specifically suggested two components because there is a typical problem, ma'am. There is no general or a generic solution fits to all. In insurance industry, what happens? Let's say, for example, if I have to give you an idea about these three sectors. So in telecom, whatever asset value, if it has a value of less than 1 lakh rupees, it does not get insured. That's a condition that is there. And most of their assets that gets failed, all those antennas or small components, have the values less than 1 lakh rupees. Now, in the power, ma'am, what is the issue? They have the maximum highly valued asset is the PT, power transformer. Again, that asset has the maximum premium and it gets maximum impacted as well. So discoms are not in a position in which they can pay the premium this much because they are already debt ridden. Similarly, ma'am, for the road, the rural roads, the district roads, they get maximum impacted and they have no coverage. Whereas if you see the national highway and state highway, it has insurance coverage linked. So we have traversed across the country, across the globe, ma'am, and we have found that insurance till date is struggling and it will take another 5 to 10 years to mature this in disaster risk financing space. So FCDO has come up with a thought that you should have a region specific vulnerability indexes developed and a proper mechanism that can certify the impacts. And it cannot happen till the time we don't have the vulnerability functions of the individual infrastructure systems that we have for the country, because there is always a problem of arbitration. So these things, ma'am, are being discussed in length and breadth across Ministry of Finance. So I could not show you because that's an ongoing project. There is a project from Ministry of Finance, Department of Economic Affairs on NIP, National Infrastructure Pipeline. There, they are specifically asking, government has invested 108 lakh crore rupees for the heavily invested sectors which has the maximum impacts. And again, the power, road, and railways are the three major heavily invested sectors from the government side under NIP. And out of that 1 lakh crore rupees, 54,000 crore rupees, 5,400,000 crore rupees are in these three sectors only. So, how to ensure their investment is a task that was given to us. We are working towards it with FCDO and Ministry of Finance and these three line ministries onto this project. And we are coming up with, I have developed a tool for the risk and resilience assessment if we have no data, and how we can have the risk adjusted values, RAV we call it, for those infrastructures for different return periods for different zones. So hill, coast, and plain, all three different scenarios. It is at a very preliminary stage. We have presented it at a COP recently, and it was widely appraised. But since that study is still ongoing and it will be finished by March 2025, so then probably I'll be able to discuss about that. There are many things into this, which is completely new for this country again. So I got a chance to work onto this project. So I'll discuss that, ma'am. Just give me 2-3 months onto this, and probably I'll give you a very thorough understanding. Probably we can share that because the tool what we are developing, it will be an open source again for everyone. Multiple scenarios. As on date, it is a desktop-based tool, but we are planning to make it a web-based very soon with the request of the government, and then it will be shared again with you all. So
thank you, sir, so much. And what you described now is really amazing, and that that brings me joy that we are going ahead in a right direction towards resilience. And when we are teaching students, they have to be taught from the beginning disaster management, the vocabulary and all. And I had the privilege of working on the Disaster Management Act when it was a bill. So I invite this FDP participants also to register in our FDP participants, which I'll be sharing in the group. So I invite all, because there you will be getting all the basics and quantification of all these disaster risks step by step.
And ma'am, just to
they can
add
learn
one,
a lot.
Yeah, and just
Yes.
to add one more point here. So if you are aware, CDR recently developed with UNDP a compendium for disaster for country. And this is just a recent development. 6 months ago, they have developed a complete disaster and climate compendium with the support from UNDP and FCD. So this is available on CDRI Coalition for Disaster Resilient Infrastructure website. Anybody can refer that. It's 300 different. So in this country, we have almost 312 disasters, right? And we are just talking about 12 and 15 max to max. So there are many because we are discussing one of the very big project with UP government, and it was surprising for us that drowning to snake bite to fire, these are the three major hazards that have more life losses than the flood in UP. This is
my God.
Yeah. So, ma'am, we are also learning over the period of time, but whosoever is interested in these domains probably can explore CDRI website and UNDP website for this. Yes, thank you.
There are many, many young architects, planners, students, engineers who are going into this direction, So I am really happy that we interacted with you. Thank you so much. Thank you to the coordinators also.
Thank you,
Thank you very much.
Thank you so
Sir, I have a
much.
question. Am I audible?
Yes, please.
So basically, this now there's a lot of this building material. When you're talking about fire, they say it should be made from fire resistant, fire resistant product, or there should be so many above fire rating. So can you elaborate how we can do that, especially in the ACP market, aluminum composite panels? How we can make it more fire resistant? ACP, and who checks it?
Sir, I don't work in the fire domain because I work in the hydrometeorological disasters. So this is where my limitation is. There is a team who works specifically on fire. So if you want, you can share your contact details with me. I'll connect you with the fire expert of PwC. He'll guide you end to end onto this. Uh, I work in hydrometeorological hazard domain, sir. So right from flash flood, GLOF to coastal flood. If you ask me, probably I'll be able to answer your any of the queries.
Yes, probably
Sure, sure,
FSCI.
sure.
You can see the FSCI website, Fire Safety Authority of India, and there are fire safety building NBC National Building Codes also, in which the land uses have been divided into different categories A, B, C, D, E, F, depending on the type of use, hazardous, industrial, educational, administrative. There is a lot to be learned. There are different categories and land uses, and then materials, and then there is a lot to learn in this also. You can go to FSCI website also.
Ma'am, I agree, but NBC 2016 is a very vast document. What I am looking at something concrete, especially either for aluminum composite panels or let's say for steel sheets. If we can have something which can have more fire rating, who test it. So if there is some easy, because NBC is a notion. If I want to go through NBC.
No, sir, it has a specific section because we have to go through building codes because we were doing one of the project for the data centers. And ultimately, I'm not a civil engineer, so I'm an electrical engineer. So my most of the works are around electrical electronic infrastructure systems. Road is an area in which I've extensively worked in a small island states to this country, to many other countries. So, and Nepal has always been a home for me to assess some sort of road risk assessment because they have the maximum impacts. So that way, I learned a little bit more about roads. But sir, it's not that it's a 1600-page document, that entire NBC, and but it has a specificity, as ma'am has said. There are many good things about NBC that they have specifically given a section, and if you Google it through, there is complete details onto it. But as far as this fire is concerned, I have noted down your queries. Probably I'll get back connecting with my fire team, or they can directly connect with you. So you can just contact the coordinators or me over the emails, or I have also noted it down. I'll revert to Swati and Madam both, so that you can get your queries answered. But this is not my
Sure, sir.
area, sir. Fire is not an area in which I work, so I don't want to give any vague answer to it.
No. Sure, sir. I think thanks very much. I will share my details to I think Devanshi ma'am. I think she already has it, and I will also get in touch with you directly. And then
Sure, sir.
and I will be grateful for your help in this. Yeah.
Thank you, sir.
Thank you, sir. It's so wonderful and mesmerizing that we are not really willing to leave you right now. But since we are short of time, I would really like to thank you for finding out time of your busy schedule and enlightening us for over a wonderful topic of this GIS applications. We look forward to having you sometime again in person and having wonderful interaction with you again. I
Thank you.
thank you
Thanks a
so
lot,
much,
ma'am.
sir. Thank you so much, sir. On behalf of the Civil Engineering Department at IPS Academy, I'm really grateful to you for being with us today.
Thank you, ma'am. Thanks a lot.
Thank you, sir. Thank you so much.
Thank you.
Thank you, ma'am.